Hello, everyone. Today I'll be talking about the facade design pattern. Facade design pattern is a structural design pattern, and it is built between the user client code and the multiple processes. So in any given case, there might be multiple processes that are run by some algorithm. And how this would work is the main method or the user should have to call these processes according to the algorithm. But what Facade class accomplishes is it's between the user and these processes. And it produces a simple interface to the user. So instead of having many sub-processes, we can have some operations which can be called by the user, which would then call all of these sub-processes needed to achieve the results. For example, in this case, we have three sub-processes. And we also have three operations. Some operations require more than one process to be completed. So what's happening here is the user, if they want the operation one to be done, they would need to call process one and two. But what the facade class is doing is the user just calls operation one, and then operation one calls process one and process two on its own. So the user does not have to worry about what's going on. They could just use the facade class to get the work they need to be done. So it's like a simple interface to the user. So this is also very common because almost everything in real life, they're not done by just one process. There are multiple things needs to be done for an operation to be completed. For example, if you go to a cafe and then just order one cup of coffee, you slide the credit card and there's a transaction happening. The operation is transaction, but it's not just one simple thing. So the sale machine is going to have to contact the bank, get the account information, make sure there's enough money, and then deduct that money and then get it to the cafe owner's account. So there's multiple sub-processes that's going on, but there's a facade there. The facade is the machine only calls a make transaction method, and then all of these behind the scenes methods gets executed. I have a very simple facade class demo here on the right. So what I have is exactly the same on the left diagram. I have three different processes, process one, two, and three. And there's a facade class between the client and the processes. So let's start from what the processes are. So we have process one, which is just an arbitrary process that does operation, that prints out operation completed. We have process two, which does the same with process two, process three, which does the same for process three. And then there's the facade class. Facade class has these processes as member methods, and then it initializes it when the facade class is initialized. It deletes them when the facade class is destructed. And there's these operations. These operations are called by the user, and they execute the sub-processes according to that algorithm. For example, in this case, operation one requires a process one and process two to be completed. Therefore, when the user calls operation one, they don't have to worry about what's going on in the other side of the facade, but the facade just executes process one and process two. So let's run this demo. And this is the output that we get. So from these print statements, we can deduct what's going on. So the first thing that's happening is the facade class is getting initialized. And then that initializes process one, two, and three. So that means that those processes are available to be used while the facade is in its usable life cycle. So as part of operation one, process one and process two is getting completed. So that is this operation right here. As part of operation two, process three is getting completed. And as for operation three, process one, two, and three is getting completed. So as we can see, the user does not know what's happening behind these operations. It just knows that I executed operation one. But operation one on the background executed these two processes. So this is the facade, and it simplifies these three processes to the user. This was a very basic demo, and I have a little bit more complex demo as well. So this is a time converter program that I wrote that uses a facade class. So in this case, it's a little bit more complicated. We have the main function, same as before. We have a driver that does all of the IO logic, and we have this facade class. So what this facade class has is it has the setup, the operator indexing, the get time method, and get error method. So the user only uses these to do time conversion calculations. But what's happening on the background is, first of all, we need to get all of the information required. So we have two CSV files. One of them is the time zones file. The other one has the time zone codes. So what the Facade is going to do first is, because we need this information, it's going to load those CSV files. That is done under the load csv.hpp file. And then what needs to be done is we need to access those time zones, and we want this to be fast. So we have a hash table. This hash table is located in hashtable.hpp. So Facade also calls that hash table HPP to access that table, get the zone information, get the time information, get the city information. And then our main logic is located in time zone. So once all of these information we got all of these information, then we can start doing the computations. For example, if you're trying to convert from one time zone to the next, the time zone would get information from the hash table, which got the information from load CSV. And then time zone returns the information back to the Facade class, which then returns it back to the user. So let's look at the code. So first of all, we have the main function. And this main function just calls the driver, which is the code that's being used from the command line. And this function has this object called Facade. So let's look at the Facade, and it has all of these functions. But first, let's look at the Facade class. So what the Facade class has is it has all of these three classes as a member method, as the same thing as the demo. And then when it's getting initialized, it initializes all of these classes, these objects, and then it also loads the table using the load table cities. And then what's happening is the user calls the setup time right here. And the setup time is calling the hash table. So the user is just calling setup. It's not, they don't know what's going on behind the scenes. But in order for setup to work is we need to get the zone from the hash table, get the time offset from the hash table, and then plug all of that information into the my time zone. So that is happening all in the Facade class. So Facade class is simplifying life for the user. It's just creating an interface. So it just has this setup, this operator indexing, which has all of the time zones for the given city. So we can plug in another city. We can say San Diego, Los Angeles, and it would give the user back a time zone. We have get time and get error. So the user does not know what's happening behind the scenes. It doesn't know about the CSV file loading, doesn't know about the hash table, and doesn't know about the computations. They only know these four methods, and that's what's important because the rest is achieved by the Facade. And then if we want to demo this one, we can see that when the program is first loaded, it loads the table zones and the time zone table. And this is done from the Facade initializer. And let's say we're at location San Diego. And then let's say the time is 8 o'clock. So now it's accessing the zone table and accessing the time zone table. This is also done from the Facade. And now we say which time zone would we like to convert to. And if we say Chicago, it's going to give us the time back from Chicago. And it's you can see it's accessing the zone table and time zone table again. The user does not know that this is happening. This is all done by the Facade class. So in the summary, Facade is a design pattern that layers our program. So it separates the methods from the user. It's in between those two things. So when the user calls a specific operation, it gets called from Facade, and Facade completes that operation with the algorithm calling all of the different sub processes. Therefore, a simple interface is established for the user.